All right, we're going to go through several different examples on how to find the derivative um, of exponential and logarithmic functions, and hopefully this will help out those that may be struggling in this area. So, without further ado, let's begin. And let me get this set up real quick. Let's begin with y equals e to the negative 5x. And let's find that derivative. To find this, we're going to take the derivative of both sides. So we're going to have y prime equals, now what e to the x, the derivative of e to the x, just for review, is equal to e to the x. All right, and since we have something other than e to the x here, we get to use this. So if we take the derivative of, sometimes in calculus books you have e to the u, and this is going to equal e to the u times the derivative of u. Okay, so in this case, we're going to have e to the negative 5x times the derivative of 5x, which is going to give us negative 5. And so we can have negative 5 times e to the negative x, or sorry, 5x as our derivative. All right, well, that was a simple one. And circle that and move on to the next one. Now, this one is a little bit more difficult. All right, and that when you have a derivative of one of this magnitude, and I'm going to take this a little bit longer. All right, we're going to find this derivative by breaking it down and using the property of logs first. All right, this is one of the tricks that you can do when you're dealing with different log functions, is that we can actually, because we're dividing, I can marry it as natural log of 1 plus e to the x, all right, minus natural log of 1 minus e to the x. By doing so, I make the derivative a little bit easier to solve. So now I can take the derivative of this new expression, which is the same as the previous, and what we get then is y prime is going to equal the derivative, just through a quick review, the derivative of x of natural log of x is going to equal 1 over x. In the same way, if I take the derivative of natural log of u, is going to be with respect to x is 1 over u prime. All right, so in doing so, we're taking the derivative of this first, which would be 1 over 1 plus e to the x, times the derivative of the inside, which is going to give me e to the x, and I'll just simplify that, and I'll put that right there. Minus, once again, now we're going to take this derivative, we get 1 over 1 minus e to the x, and then I'll take the derivative of the inside, which will give me negative e to the x, which will make that positive then, and I'll just have e to the x right there, because the derivative of this inside expression is going to be negative e to the x. And so I have this. If we wanted to, we probably could simplify and factor out e to the x and whatnot, but we'll just leave it right there. All right, our next problem we have is e to the negative 3 to the over 2t squared. I'm going to rewrite this as e to the negative 3 times t to the negative second. Just make it a little bit easier for us. Find this derivative of g prime of t is going to equal e to the negative 3 t to the negative second times now the derivative of the exponent, which is our u, using a chain rule. And what we have then is going to be 6t to the negative 3, negative third. We can simplify this, and having 6 e to the negative 3 over t squared all over t cubed, and that would be g prime of t. All right, so those are 3 examples of using logs and exponentials and how to find their, differentiate them. And let's try some other examples. Let's try this one where we're going to do a second derivative. Okay, a second derivative. So we're going to do the derivative twice. And we have a combination of an exponential and we have a log of x. So in doing this one, we can take the derivative of g of x, take the derivative using the sum properties, and or the sum rule of differentiation. We have 1/2 x to the negative 1/2 power. Okay, and now we're going to use the product rule for this one. And in doing so, what we have then is going to be equal e to the x times the natural log of x, because the derivative of e to the x is e to the x. So take the derivative of the first, using the product rule, plus now the derivative of the second, which is 1 over x, because that's the derivative of the natural log, times e to the x. Okay, we can simplify this a little bit. We'll keep this here. Simplifying always is nice. And we can factor out an e to the x there. And we have natural log of x plus, I'm going to write it as x to the negative first because we are going to find the second derivative of this now. So it's the first derivative. So now I'm going to change colors and find the second derivative of this new expression. So find the second derivative. The reason why we're doing this is because I asked, but also if you want to find the acceleration of this, this is an object in particle motion. But, so here we go. We have negative 1/4 x to the negative 3/2 power. We are now going to use the product rule. Once again, we have plus e to the x times this quantity, natural log of x plus x to the negative first, plus now the derivative of the natural log of x, which is 1 over x minus x to the negative second power, and all that times the first function, which is e to the x. All right, and there we have it. If you wanted to, we could maybe simplify this expression a little bit farther, just for fun. Oh, hello. Sorry about that. And since we all are about fun, we'll write for x to the 3/2. I'll factor out again in e to the x. And so now we have natural log of x. This is, we'll add those two together. This is 1 over x as well. And now we have two of them. So now we'll have 2, 1 over x. And then we'll have minus this 1 over x squared right there. And we can kind of leave it like that. And then it's g double prime. All right. Okay. I'm going to go one more. And I'm going to find this derivative. This is using implicit differentiation. Implicit differentiation. Okay, on with this exponential. So in order to solve this, we're going to find dy dx right here. What we have is e to the xy. So I'm going to take e to the xy, take this derivative, both sides. And when we have, then I have to multiply by the inside, which is going to be, or the exponent that is. Using a chain rule, we have y plus y prime times x plus now 2x minus 2y, y prime equals 0. All right. Now we get all the y primes by itself. So in order to do this, I'm going to factor the e to the xy through. So we have e to the xy times y plus x times e to the xy times y prime. I'll just put it there. 2x minus 2y, y prime equals 0. Moving on a little farther, we are now going to get all the y primes on one side, so I'm going to subtract y, e to the xy to the other side. I'll also subtract 2x. And then over here, I'm going to factor out this y prime right away. And what I have is x e to the xy minus 2y. And then finally, y prime, or dy dx, so you know it's the same thing, is going to equal negative y e to the xy minus 2x all over the quantity x e to the xy minus 2y. All right, so we went through implicit. We did some normal ones. We did a second derivative. Hopefully this will help you out in solving some exponential and some logarithmic functions.